The next feature we need to find is the y-intercept. The y-intercept is on the y-axis, which means it is a point with 0 as the x-coordinate. So we need to substitute 0 in for x in the equation. Now we have the equation y equals a negative 0 squared minus 2 times 0 plus 3. As we simplify this to solve for y, the first two terms both equal 0. So we have 0 plus 3, which is 3. This gives us the point 0, 3 as the y-intercept. So we plot that point on the graph. Notice that for this form, the y-intercept will always end up equal to c. So you can just look at the equation and write the value down. Finally, we need to find the x-intercepts. The x-intercepts are points on the x-axis, so the y-coordinates equal 0. To find the x-intercepts, or zeros, we substitute 0 in for y and solve for x. The equation we get, 0 equals negative x squared minus 2x plus 3, is a quadratic equation, and we could solve it by factoring or by the quadratic formula. This one is pretty easy to factor, so we'll do it that way this time. First, we need to get rid of the negative 1 in front of the x squared, so we can divide both sides of the equation by negative 1, which will change the signs of every term to give us 0 equals a positive x squared plus 2x minus 3. Now we have a trinomial that will factor into x plus 3 times x minus 1. And we can use the zero product property to find the roots. X equals negative 3 or positive 1. Now we know the two x-intercepts are negative 3, 0 and 1, 0. We'll plot these on the graph and label them with z's because they show us the zeros. Notice that the x-intercepts are both two spaces away from the point where the axis of symmetry crosses the x-axis. That's because the parabola has symmetry. If the x-intercepts you find are not evenly spaced on either side of the axis, then you know you did something wrong. Finally, all we have to do is connect the points we have with the curve. And we're finished with the parabola.